Hello, I'm Richard Montagna, Senior Vice President for Scientific and Clinical Affairs at Rheonix. The following presentation, entitled A Rapid Screening and Confirmatory Assay for HIV, describing the simultaneous detection of anti-HIV antibodies and viral RNA, was given on April 8, 2015 at the AACC's Point of Care Testing Virtual Conference. This work represents a collaborative effort between scientists at NYU and here at Rheonix. This work was funded by an NIH SBIR Phase 1, Phase 2 Fast Track grant in the amount of about $1.7 million and focused on developing a fully automated dual assay for detection of both antibodies and viral RNA in saliva or blood specimens, and it was intended for use in low resource settings. Now, the original assays were developed at NYU using manual benchtop methods, and during the course of this work here at Rheonix, we converted the original labor-intensive manual assay into a fully automated assay using our proprietary card technology. In order to perform this dual assay, our first challenge was to develop a buffer system that would not only lyse viral particles to release viral RNA, but also preserve antibody immunoreactivity in the sample. Our initial efforts demonstrated that buffer systems that effectively lysed viral particles were too harsh to preserve antibody activity. Conversely, buffer systems designed to preserve antibody activity were not strong enough to lyse viral particles. Ultimately, we developed a pluronic acid buffer system that would allow both assays to be performed simultaneously. Once we finalized that buffer system, we turned our attention to establish the various conditions necessary to perform the original benchtop assays on our fully automated card platform. The ability to perform these two assays simultaneously offers several advantages. First, it provides a means to automatically and immediately confirm any seropositive results that may have initially been obtained. Those of you familiar with HIV diagnostics are aware that initial seropositive results are generally confirmed by more sensitive and specific tests. By automatically detecting viral RNA, we can immediately confirm the HIV status of the individual being tested. In addition, the molecular detection of viral RNA also overcomes the well-known seronegative window period that occurs during early HIV infection. Although such an individual may give negative serological results, high concentrations of circulating and highly infectious virus is already present. Therefore, being able to monitor for the presence of actual viral RNA will give healthcare workers a better understanding of the HIV status of the patients. Finally, the design of the fully automated assay allows individuals to perform both assays without any extensive training, which would be obviously very useful in low resource settings. The microfluidic device we call a card, which is an acronym for chemistry and reagent device, is able to simultaneously analyze 4 separate specimens. The image in the top left shows a schematic of the various microfluidic channels for each of the 4 separate sets of channels. It also shows the reagent and reaction reservoirs. This card contains all necessary pumps and valves that are created as part of our fabrication process. The image on the upper right is an actual photograph of the card where you can see 4 adapter ports here, 1, 2, 3, and 4, that are located on its surface into which we can place saliva or blood swabs for the performance of the assay. And then the image on the bottom is just a side view where you can see the adapter ports and one of the swabs has been inserted. Now, to give you a sense of size, here's an overlay of a credit card above the card itself. Now, the card itself is produced by inexpensive injection molding methods, and although it consists of multiple components, it's fabricated as a single piece to yield a monolithic plastic device. To run these assays, we have modified our benchtop EncompassMDx workstation, which is capable of processing up to 24 individual samples, into a smaller portable device we call the EncompassMDx SOLO. This portable device weighs approximately 25 pounds and allows one card into which 4 specimens can be analyzed simultaneously. Now, the only manual step that's required to be used by the user is the insertion of the swabs, with all other steps automatically performed under the control of software. Once the pluronic acid buffer is introduced, 20 microliters is immediately processed through one set of microfluidic channels on the card to detect antibodies to HIV in a lateral flow format. This step takes approximately 7 minutes to complete. Now, simultaneously, while that's occurring, the remaining material is processed through a second set of microfluidic channels to lyse the virions, extract viral RNA using silanized magnetic beads, and the resulting viral RNA amplified using loop-mediated isothermal amplification, or LAMP. That process takes approximately 15 minutes, not including the approximately 40 minutes it takes to prepare the RNA for analysis. Now, since all of these steps take place simultaneously, both assays are completed in just under 1 hour. Here are some representative results obtained analyzing 3 seropositive and 1 seronegative specimen. Each of the lateral flow test strips is striped with a positive test line that consists of recombinant envelope proteins and a control line that consists of anti-human IgG. As expected, both lines appear in the seropositive samples, which are samples 1, 2, and 3, and only the control line appears in the seronegative sample here on the right. To get a sense of the reproducibility and analytical sensitivity of the assay with respect to antibody detection, these 4 samples were evaluated over 5 different days at various dilutions. You'll note the presence of both the control and test lines in all of the seropositive specimens, here 1, 2, and 3, and then you'll see other replicates across here, and only the presence of the control line in the seronegative specimen, which is the 4th one in each set. Now, as previously noted, while this serological assay is underway, the specimens are also simultaneously and automatically prepared for molecular amplification of the HIV-GAG gene using LAMP. Using matched sets of saliva and plasma, the system is able to detect viral RNA in approximately 10 to 12 minutes, with similar results in both plasma and saliva. In order to get a sense of the limit of detection, clinically relevant concentrations of virus were spiked into these 2 matrices, and as you can see, we can detect viral particles at concentrations down to about 10 to the 3rd viral particles per ml in both matrices. Now, the results presented thus far were resulted from our Phase 1 efforts, which we concluded just a few months ago. Now, currently, our Phase 2 efforts, which has been funded by the NIH, are focused on further reducing the time to results from the current time of about 60 minutes, and we expect to shave off about 15 or 20 minutes in total assay time. We also are further simplifying the instrument by incorporating the use of lyophilized reagents to not only improve the shelf life of the reagents, but also the shipping and storage requirements. In addition, the Phase 1 instrument was controlled by software on a laptop computer connected to the EncompassMDx SOLO. The Phase 2 efforts are incorporating firmware into that same instrument, thus eliminating the need for an external computer. Now, once we've completed these efforts, we'll then evaluate the clinical utility of the system by analyzing additional clinical specimens, and at the same time, we'll also establish the clinical sensitivity and specificity of this dual assay. And finally, we'd like to acknowledge the support of the National Institute of Dental and Craniofacial Research for the funding necessary to perform this work. We thank you for your attention.